Dear students, I would like to present to you the concept of the conditional density functions associated with the bivariate normal distribution. So what I'm going to do is to present to you a derivation through which I will show that the conditional density functions related to the bivariate normal distribution are themselves normal distributions. So let us start with the PDF of the bivariate normal distribution. As you already know, it is as follows. F of xy is equal to 1 over 2 pi sigma x sigma y into square root of 1 minus rho square, all of this in the denominator, multiplied by e raised to a pretty long lengthy expression, but a very important expression. And what is that? It is minus 1 over 2 into 1 minus rho square, and this thing multiplied by x minus mu x over sigma x whole square plus y minus mu y over sigma y whole square minus 2 rho into x minus mu x over sigma x into y minus mu y over sigma y. As you know, for this density function, both x and y go from minus infinity to infinity. And obviously, we have 5 parameters, mu x, mu y, sigma y, and rho. And the restrictions on sigma x and sigma y are that they have to be positive numbers, and the restriction on rho is that it should lie between minus 1 and plus 1. All right, given this bivariate density function, my dear students, let us now attempt to derive the PDF of the conditional distributions associated with this one. So how do we begin? We begin with the basic definition of conditional distribution. As you already know, if we have f of xy, a bivariate distribution, then the conditional distribution of y given capital X equal to small x, some particular value small x, this conditional distribution is expressed as follows. F of y given small x is equal to f of xy divided by f of x, where f of xy, of course, is the joint PDF of x and y, but f of x, which occurs in the denominator, that is the marginal PDF of the random variable x. So now, if this is the basic structure, the basic formula, you can say, for any conditional distribution, let us apply it in this situation that we have in front of us. Obviously, the expression will be as follows. F of y given x small x is equal to, अब जैसा कि आप देख रहे हैं स्क्रीन के ऊपर, in the numerator you write that lengthy expression which is the PDF of the joint distribution, which I shared with you just a short while ago. And what do you put in the denominator? F of x जो है, marginal distribution of x जो है, bivariate normal के केस में, do we not already know that the marginal distributions are themselves univariate normal distributions? Of course, that is the case. So therefore, what do we write in the denominator? The same thing that we should, 1 over square root of 2 pi into sigma x multiplied by e raised to minus half x minus mu x over sigma x whole square. यानी जो PDF होता है, आम जो होता है, obviously वही आप वहाँ पे insert करेंगे. All right, now that we've done this, let us now focus on the exponent, यानी power में जो चीज़ है, let us focus on that expression. Which exponent? the exponent which is occurring here in the numerator. All right, the expression is in front of you, and now I'm going to do some algebraic manipulation with it. So the first step that I will do is to multiply and divide this expression by sigma square x into sigma square y. और हम करेंगे क्या कि जो हमने मल्टीप्लाई किया है उसको हम अंदर ले जाएंगे, जो हमारा स्क्वायर ब्रैकेट है उसके अंदर जो 3 टर्म्स हैं उन सब के साथ उसको आप अटैच कर दें, और जो डिवाइड किया है उसको हम बाहर रखेंगे. एंड देन आफ्टर दैट ऑफ कोर्स जो अंदर ले गए हैं जो टर्म्स कैंसिल आउट हो जाएंगी, we will cancel those, and therefore what do we get at the end of this step? We get minus 1 over 2 into 1 minus rho square into sigma square x into sigma square y, and this entity multiplied by a lengthy expression in the square bracket, and the expression is sigma square y into x minus mu x whole square plus sigma square x into y minus mu y whole square minus 2 rho sigma x sigma y x minus mu x into y minus mu y. इसके बाद students, we are going to do the process of completing the square. And how do we do that? I'm going to add and subtract the term x minus mu x whole square into sigma y square into rho square. ये term मैं add और subtract करूँगी inside that square bracket. And after that, I will put together the second, third, and fourth term. And also I will put together as another bunch the first and fifth terms. वो जो second, third, और fourth हैं, they give you the expression sigma x into y minus mu y minus x minus mu x into sigma y into rho, and इस पूरी चीज का whole square. And how do we get this one? Students, is the basic formula a minus b whole square is equal to a square plus b square minus 2ab. तो अगर आप गौर से देखें तो इससे पिछले स्टेप में वो जो 3 टर्म्स थी वो एग्जैक्टली यही थी, और उसकी वजह से अब जो एक्सप्रेशन आता है वो ये है जो मैंने आपके सामने रखा. उसके बाद वो जो दूसरा बंच है यानी फर्स्ट और फिफ्थ टर्म्स, उनमें से जो चीज़ कॉमन निकलती है उसको कॉमन निकाल लें. एंड डूइंग दैट what are we left with? We have sigma square y into x minus mu x whole square into 1 minus rho square. So this entire expression is now in front of you on the screen, and you can also see that we have to do some further algebraic manipulation as well. And after that, my dear students, we are going to substitute the final expression that we get after all this algebraic manipulation in that original expression that I presented to you, the expression of the conditional distribution. So now you can see that on the screen. F of y given x is equal to, in the numerator, the PDF of the bivariate normal distribution, but the exponent written in the form that I just now presented to you, that you saw on the screen after a number of steps. And what is that expression? E raised to what? Minus 1 over 2 sigma y square into 1 minus rho square multiplied by y minus mu y minus x minus mu x into sigma y over sigma x into rho, and this whole thing square. And then also with it we have another term in the exponent, minus 1 by 2 x minus mu x over sigma x whole square. उसके बाद जैसा कि आप देख रहे हैं स्क्रीन पे, वो जो बाद की टर्म है अगर हम e raised to that अलग से लिख लें तो ये कैंसिल हो जाती है with the expression that we have in the denominator. All right. So now that that term is gone, we have a little less left to deal with. अब आप देखिए कि जो एक्सपोनेंट के अलावा जो है वो क्या है. In the numerator we have 1 over 2 pi sigma x sigma y into square root of 1 minus rho square, and in the denominator we have 1 over square root of 2 pi into sigma x. So obviously यहाँ भी कुछ cancellation होगी. And doing all that, my dear students, the final version is as follows. 1 over square root of 2 pi into sigma y into square root of 1 minus rho square multiplied by e raised to minus 1 by 2 sigma y square into 1 minus rho square, and this entity multiplied by something whole square, and that something is y minus inside bracket mu y plus x minus mu x into sigma y over sigma x into rho. ये आपके सामने है स्क्रीन के ऊपर, और बज़ाहिर ये काफ़ी कॉम्प्लिकेटेड एक्सप्रेशन नज़र आता है, लेकिन एक्चुअली माय डियर स्टूडेंट्स, I will make two substitutions and you will see that this is the PDF of a normal distribution. So what I'm going to do is this. I'm going to let sigma y square into 1 minus rho square be equal to sigma tilde y square. And also I'm going to let mu y plus x minus mu x into sigma y over sigma x into rho be equal to mu tilde y. अगर मैं ये substitutions उसके अंदर करूं तो मुझे क्या मिलेगा? I obtain 1 over square root of 2 pi into sigma tilde y multiplied by e raised to minus 1 over 2 sigma tilde y square, and this entity multiplied by y minus mu tilde y whole square. So you can recognize it, I'm sure, very quickly as the PDF of a normal distribution, the mean of which mu tilde y is actually equal to mu y plus x minus mu x into sigma y over sigma x into rho, and the variance of which sigma tilde y square is actually equal to 1 minus rho square into sigma y square. अगर आपको थोड़ी सी यहाँ पे confusion है कि ये इतना लंबी सारी चीज़ें हैं, ये कैसे, तो इसमें इतना परेशानी की बात नहीं है. आप ये नोट करें कि रो जो है that is a number, constant है ना, it is some number. और इसी तरह sigma y, sigma x and also mu y, mu x, they're all actually constants, they are numbers. So therefore your new mean can be equal to this expression that I have presented to you, and your new variance can be equal to this expression that I have presented. हाँ, एक चीज़ आपको ज़रूर थोड़ा सा बॉदर करेगी कि आप कहेंगे, और आपको कहना चाहिए, कि ये म्यू और सिग्मा और रो के अलावा भी तो एक चीज़ है ना उसके अंदर. ये जो मैंने नई डिस्ट्रीब्यूशन की मीन आपके सामने रखी है, मैंने ये कहा कि इट इज़ म्यू वाई प्लस एक्स माइनस म्यू एक्स इंटू सिग्मा वाई और सिग्मा एक्स इंटू रो. तो बाकी चीज़ें तो चलें कांस्टेंट हो गई, बट देन व्हाट अबाउट एक्स? एक्स खुद एक्स भी तो आ रहा है उसके अंदर. तो फिर आप कहेंगे कि एक्स तो रैंडम वेरिएबल है, देन हाउ कैन वी से कि दैट इज़ अ कांस्टेंट? So this is a very, very important point, my dear students. Whenever we talk about a conditional distribution, like we are doing here, यहाँ पे हम निकाल रहे हैं the distribution of y given x. So the moment I say given x, I mean some particular value of x. इसलिए यहाँ पे ये जो x भी जो है ना, it is not a random variable. It is one particular value of the random variable, capital X.